So, good morning everyone. Today I'll be presenting my paper Augmenting Context-Aware Citation Recommendations with Citation and Co-Authorship History, where me, Manmata Bhaumik, I'm the first author, then Ashish Singhal and Professor Dr. Shengwei Wang, who is a supervisor from the University of Twente. Let's start with the overview. So, scientific work has increased tremendously over the recent years, and that's why the proper citation has become the need of the hour. There's been a lot of scientific work recently, and that's why we need quality citations to show that the quality of the paper is immense. And this can be done by citation network and author collaboration, which shows the quality of the paper. Citation network shows that that papers are being cited many times, saying that this paper has a high quality value. Similarly, the author collaboration says the more the author collaboration, the better you are as an author. So, citation quality can also be checked by global and context based citations. So, let's talk about citation prediction. Citation prediction or citation recommendation is defined as the task of recommending citations from a textual context. So here you can see an example of a citation where ref is our citation from the papers and that is surrounded by context. So depending on the length of the citation context that are used for recommendation, we can say the citation are two types. One, global citation, and two, context aware citation. So what is global citation? If we take the entire text surrounding the citation, like we take the entire text surrounding the citation along with the abstract of the paper, then that is called global citation. However, if we decide to take a short length window of words surrounding the citation, then it is called a context aware citation. So from this example, we can say, let's say take 5 words surrounding the citation. So we take something from here to here. That is called context aware citation. So we started by data preprocessing. The first step was we took the peer-read dataset. This dataset actually consists of papers from ACL 2017, archive from 2007 to 2017, computational natural language learning conference 2016, ICL 2017, and NIPS from 2013 to 2017. Hence saying that the dataset is very huge. Now, as the dataset is large, we had to clean it. We had to clean the dataset, and we kept the records holding citation paper ID, citing paper ID, cited paper ID, text to the left of the citation tag, text to the right of the citation tag, the target year, basically saying the release year, and the source year of the paper. However, the dataset was still large, and we decided to keep a citation frequency. So what is citation frequency? We say that papers who have been which have been cited more than a certain frequency, take them. So for we kept the citation frequency at 5, saying if a paper has been cited more than 5 times, we will keep that in the dataset. So the dataset was finally termed as full text peer-read dataset, and the total number of papers that were taken were 4,898. The total number of base papers were 3761. The total number of cited papers from the base papers were 2478. The total number of citation context was 17,247. That includes both the left-sided text and the right-sided text. And the total number of unique authors were 9,529. In this case, the unique authors are basically supervisors in the CS domain, as our dataset consists of papers from the CS domain. And the years of paper we used from 2007 to 2017. So we extended on the previous research work of Jiang and Perk 2020, who developed a context-aware citation recommendation with BERT and GCN. So why did they use that? BERT is one of the highest performing pre-trained models for NLP learning representation. They expected actually that the learning representation of context sentences through pre-trained BERT here will achieve the best performance. They use the GCN model to represent the citation relationship between papers and to extract a learning representation of them. This was then concatenated and sent to a feed-forward neural network with softmax activation function. From that we got the probability of the citation labels, and these were tested on the mean average precision, mean reciprocal rank, and recall at k. So after that we took this model and implemented it in our code, and the initial result we got from a previous model, from this exact model, showed that our bird base actually performed well than what was mentioned in the paper. It actually it was actually the bird base was around 2% better than what was reported in the paper. However, the bird GCN was almost equivalent to what was in the paper. Hence, we decided to keep the results we got from our model as our baseline model for our future experiments. So what are the experiments and the enhancement ideas we got? So co-authorship network, that is our main goal of this project. So we decided let's try a co-authorship network. Co-authorship network could add meaningful insight to the overall model prediction, because authors actually play a very important role when it comes to writing a paper. So can a combination of co-authorship network along with the citation network enhance the model prediction, or does only co-authorship network gives us a better response, or does it not? Another question we wanted to answer is, does domain-specific BERT, SciBERT, which is basically the domain of academic CS papers, affect the overall performance of the model? So what is a co-authorship network? Co-authorship network is a form of association in which two or more researchers jointly report their research results on some new topic. Therefore, co-authorship network can be viewed as a social network encompassing researchers that reflect collaboration among them. Co-authorship network considers the relationship between the authors and their previous collaborations. For our experiments, we consider the last author, that is the supervisors, and their collaboration with other supervisors from different papers. So this is our proposed model where we replace the citation network with a co-authorship network. From the BERT, basically we can say is like it is almost the same as what was mentioned in the paper. Sorry. So how does this work is basically the context around the citation is the input to the BERT model, which are trained on which on training learns context features representations and generate contextual embeddings here. So from now, for each context sentence, so we send one sentence at a time. So for each context sentence passed to BERT, the corresponding paper's co-authorship network is also generated by the GCN. So how do we take this? That we take the embedding for the last author, who is often the supervisor in the CAS domain, and then we concatenate it with the BERT's model in this layer and send it to a feed-forward neural network with softmax activation to get the probability of the citation labels. Let me also tell you what happens in the GCN network. So here the GCN co-authorship encoder basically conducts unsupervised learning for co-authorship network, linking a prediction with the GCN based variational graph autoencoder model by using author relationship between papers as input variables. So when author information is being used as the input to a pre-trained GCN, the model returns the learning representation as the embedded vector. VGI, what does VGI do here is like VGI basically captures the latent learning representation of the graph data, which is basically what we told earlier, that co-authorship network is often a social media type of network. So the results that we got from the BERT GCN clearly indicated a possibility that co-authorship can add a good meaning to the model. As we can see, it was able to beat both the BERT and the BERT GCN model we took as our baseline. So now we decided, let's try to incorporate all the networks along with the context embeddings from the BERT and see if we can find a meaningful solution to this. So we followed the same process we did earlier. We took each context sentence passed to the BERT, the corresponding paper citation here, the corresponding paper citation embedding, and the embedding of the last author from that paper is concatenated with the BERT's context embeddings and then sent to a feed-forward neural network with the softmax activation function to get the probability of the citation labels. The results, actually we termed this model as our BERT GCN square model, and the results from the BERT GCN square model clearly indicated that the performance is very good than what was actually mentioned in the paper. We can see that it actually managed to beat all the previous scores, and which is basically almost as far as I remember, almost 3% better than what was mentioned in the previous paper or a related works paper. So this is just the model, but we also decided there is a chance that adding domain specific data could make this model even better. So there are times when a text data is domain specific, like legal, financial, academic, or otherwise different from the standard text corpus that is used in the BERT based model. So we thought that we might want to consider using this domain specific BERT. So we went on and checked for a domain specific BERT and found about SciBERT. So SciBERT is a pre-trained language model based on BERT to address the lack of high quality large scale level scientific data. So SciBERT, what does it do? It leverages unsupervised pre-training on a large multi-domain corpus of scientific publications to improve performance on downstream NLP tasks. So we followed the same model as we discussed before, and the results on the SciBERT were actually very promising. It managed to beat all the scores that we got before, and it's currently the state of the art result. So you can see the SciBERT base and DCN author, this SciBERT DCN citation co-authorship, all of them managed to beat the scores with the BERT based model. But we wanted to see was whether SciBERT GCN square can beat our BERT GCN square, and it beat our BERT GCN square by over 2%, technically saying that we've beaten the scores from the original paper by almost 5% when it comes to mean average precision and mean reciprocal rank. And for the recall at K, we managed to have an improvement of over almost 10%. So this shows that co-authorship network as well as this domain specific BERT actually adds a lot of meaning to a machine learning model and can be used to predict quality papers. So what is the future? So accordingly, what we have done is basically we have used one supervisor for the co-authorship network, but we want to add the first author to check whether adding the first author adds meaning to the co-authorship network or not, and how does it actually affect the model. So we want to add the first author, then slowly add the rest of the authors in order to create the co-authorship network. Then we want to also use the author information and the citation information. Currently we are having featureless nodes in the graphs, but we want to use author information such as H index or citation information such as publication venue, year of publication as features of the nodes in the DCN modules to check if they add meaning to our data or not, if they add meaning to the model, or do they actually add more noise to it. So this is the way we want to carry out the research in the future, and hopefully we can get good results out of it. So thank you very much, and if you have more questions you can always reach out to us at our emails given. So thank you.